go, here we go. Here we go, here we go. Here we go, here we go. Here we go, here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go. Hello, ladies and gentlemen, and welcome to another episode of Containers from the Couch. Today, I'm excited to have guest speakers from AWS, as well as a guest speaker from Upbound. I'm super excited to get our episode started today. By the way, if you're watching and tuning in, drop a message in chat. Let us know where you're tuning in from. Let's go ahead and start with a round of intros before we get into talking more about Crossplane. And we've also got a great demo for you lined up today. Let's start with my co-host today, Justin Garrison.
Hey, how's it going, Sai?
Great. How are you?
I'm doing just fine. Ready to see what Crossplane's up to. I've been playing with it a lot lately and even gave a couple talks myself. So it's always fun seeing where the community's going and what demos we're showing off.
All right, let's start with the AWS folks here.
Sure, I can go first. Nima. Good afternoon, everyone. Nima Kaviani. I'm a principal solutions architect, working with our strategic customers on open source technologies. And Crossplane has been a technology that we've been involved with for almost 2 years now, working very closely with Upbound and our friends at the Crossplane open source community. And yeah, happy to be here.
Awesome. Manabu?
Yeah, my name is Manabu McCloskey. I'm a solutions architect for the strategic accounts. I'm in the same team as Nima. And yeah, we got some great demo for you guys to look at.
Super excited for it. Manabu is gonna start with, not start with, but at least show off the demo of Crossplane today. Last but not least, our guest speaker from Upbound, the creators of Crossplane, Dan.
Hey, folks. Super glad to be here. I appreciate y'all having me on. My name is Dan. I am a maintainer of the Crossplane project and been working on it for a number of years. I am a principal engineer at Upbound. And as Sai said, we started the Crossplane project a few years ago and then donated it to the CNCF. So we have a vibrant open source ecosystem now, and super excited for folks like AWS to be involved with that. So these types of collaborations are always super exciting for us as a company and even more exciting as a community.
Love to hear it. And you know, open source software and projects, we love to feature on Containers from the Couch. By the way, can I just say it's awesome to see folks tuning in from all over the world here, from Philly, Netherlands, Canada. This is very, very, very cool.
And basements. We got everything covered. It's awesome.
That's great.
Canada, man. I'm from Canada. So yeah, it's awesome to see folks from Canada.
Nice. So folks, we know that when we talk about this topic, you know, it's DevOps, it's GitOps. There's so many terms in this space. For our folks that are tuning in and want to learn a little bit more about Crossplane, it's probably a good idea to do a little bit of setup to understand why are we even talking about this? Why is it a big deal? Nima, I want to kind of point this first question to you. What's the kind of impetus behind Crossplane and why should we here at AWS care about it, and why should we care about it for our customers?
Yeah, thank you, Sai. That's a great question. And let me switch to the slides real quick so that we can go over, maybe a very quick run through of why people choose Crossplane. So you see my screen now?
Yep, there it is.
Okay, great. So, this shouldn't be a surprise to anyone on the call. We've seen infrastructure transition from physical machines to virtual machines. Then containerization started, and, serverless is another way that people try managing infrastructure, right? So containerization is a good way for people to be able to utilize more of the compute resources, but also better control the spin up of their resources, the management of their resources. And when it comes to containerization, this term is not unfamiliar to the folks on this call, I hope. Kubernetes has been or has become the de facto container orchestration platform that a lot of people use to run containers, right? And a lot of the appeal that we see at AWS with our customers is also around wanting to standardize practices around Kubernetes. So customers generally want to optimize things when it comes to cost, reliability, security, and productivity. They want to make sure that they get the best of all worlds when it comes to these main concepts, and they want to have a common standard way of approaching these problems, right? And when it comes to Kubernetes, they are looking for solutions that can solidify their practices or, standardize their practices, right? So the question is, how can this be done? If you're using EKS from AWS, there is a lot of integrations that we've done with EKS with other AWS services. When you spin up an EKS cluster, which is, by the way, the AWS variation of a Kubernetes cluster that you can go and launch from AWS, as soon as you actually launch an EKS cluster, you actually pull in other services from AWS. You start pulling in ENIs, EC2s, EBS, Route 53, etc., etc. So when it comes to standardizing on practices and using other services, the question is, can we expand this model so that through EKS, you can start using other AWS services? You can start using SQS. You can start using, databases, RDS, S3 buckets. How can we make it so that, Kubernetes becomes the front door and the entry points for a lot of the people who want to use containerization, but want to use it with other AWS services? Well, there are technologies out there, right? And, we are here for one of the key technologies that is an enabler to achieve this. At AWS, we have AWS controllers for Kubernetes that expands or extends the Kubernetes control plane so that you can actually interface with other AWS services. But we have Crossplane too. We have Crossplane as a CNCF-based project that expands and extends the Kubernetes control plane, allows you to interface with AWS services, but allows you to go way beyond that. It allows you to define abstractions. It allows you to define packaging. It allows you to define versioning and, define the practices of your end user developers around Kubernetes interfaces and Kubernetes APIs. So that is the very high level idea or basically explanation on why Crossplane and why standardization around Kubernetes. And with that, we have Dan on the call. So I'd like to pass it on to him so that he can go and do a deeper dive on why Crossplane. Okay.
Definitely. And hey, Dan, before you jump into that, I just want to very quickly take a step back and try to understand the scope here, right? Because we're saying that we want to be able to automate the creation of services on AWS. But, that fact alone is nothing new. We've been able to do this for basically ever, using like CloudFormation. There's other tools out there, CDK, Terraform, et cetera, for creating services on AWS. But critically, I think what you mentioned here, Nima, was to be able to use Kubernetes to be able to drive the creation of these services. And today, I think that's what we're going to be focusing on, right? It's automating these using Kubernetes itself and Kubernetes constructs. And I think that's really the core of what we want to show here.
Yeah, absolutely. I think that's a really good point. And there's sometimes comes up, beyond just the conceptual model of moving to just provisioning infrastructure to platform building, which is kind of what we're going to be talking about today. Why would you use Kubernetes, right? There's some great advantages in the ecosystem it's built. But really one of the big parts for us in the Crossplane community is the tooling that's grown up around Kubernetes, right? Lots of folks leverage all different types of tools to interact with Kubernetes clusters, and maybe they start off using it for container orchestration. There's lots of tools around GitOps. I think we might see some of them today. There's tools around policy and management, and bringing this infrastructure provisioning process and this platform building process to the Kubernetes API allows you to leverage that huge ecosystem and not re-implement everything yourself. So we definitely in the Crossplane ecosystem are excited about leveraging Kubernetes toolings and leveraging cloud providers, right? I would say that the Crossplane community is probably one of the most advanced consumers of cloud providers because of the experience with interacting with those, right? It's a bunch of platform engineers and SRE type folks. So we really want to harness all of that power that cloud providers like AWS offer and offer that in platforms that folks can build and grow over time within their organizations.
Definitely. And I think one of the things I'd love to see is an understanding of how this stuff actually works beneath the covers. I know that there's a lot of different concepts here to be able to, before we even get into the demo, that we need to probably understand. Dan, do you have something that can kind of help lay out the foundation or maybe the basics of Upbound for us, or Crossplane, I should say?
Yeah, absolutely. And we'll start with this high level overview, and maybe as Manabu goes through the demo, we can kind of pull back and look at specific operations for what's happening in the cluster. But I see we already have the slides up here. What we're looking at here is kind of a sort of chart of abstraction on cloud providers, right? So we're showing it across multiple. Doesn't actually have to be a cloud provider. Crossplane can actually target any external API to the cluster, or even APIs within it. But really what we're saying is there's different services that are offered by cloud providers. So for example, if we treat the y-axis here as a level of abstraction, you could see on the AWS block, maybe that highest level of abstraction is something like Lambda, right? Maybe the lowest level of abstraction is something like EC2. What we want to do is say, hey, there's a lot of work that's gone into building these services that are super resilient and give us building blocks for constructing our own software products on top of it. What we want to say is we want our own interface into those that we control. And so you can imagine Crossplane as taking that picture and putting a layer on top of it and saying, I want to kind of filter how these abstractions flow through into my internal developer platform. And if we're using Kubernetes and Crossplane for that here, we're able to leverage all those tools that we were just discussing, right? Maybe I want to use something like Open Policy Agent to say, hey, my concept of a VM in my organization translates to this type of an EC2 instance on AWS. And there's some sort of policy that governs who can provision that at what point and what size and limits can be around that. And I can grow and change that over time. Maybe at some point, AWS comes along with successor to EC2, or maybe more likely some alternative service that's giving VMs as a service, and you want to switch over to that same interface that you offer to developers within your organization is going to stay the same, and you as a platform team are able to just change your developer platform to target that new abstraction. So it gives you a lot of power, and that's really what we're moving towards. And I know we've mentioned infrastructure provisioning and some of the tools around that. And Crossplane actually even leverages some of those tools in some places. But what we're trying to get to is building this platform rather than just provisioning and consuming infrastructure.
So Dan, how did Upbound come up with the name for Crossplane?
Yeah, so it's been a winding road. Projects evolve in interesting ways, and especially when you're doing something kind of from the beginning out in the open, which is definitely the model with Crossplane. It certainly was not hey, let's build this internally and then release it to great fanfare, right? It was hey, let's put out our idea for what we want to build and have the community join us from day one. So there's been some evolution. Part of it is kind of, this slide that we were just looking at, where there's lots of different APIs and we want you to be able to move across them. And it's a control plane that moves across clouds or abstractions or services. We had a lot of folks at various periods of time trying to leverage kind of a multi-cloud strategy. Turns out a lot of folks actually just use a single cloud provider or a single infrastructure service. And really what we're saying is you have the ability to move across those services, regardless of if they're on different clouds or on the same one, and they can change with your organization over time. So that's kind of the impetus for the name. Popsicle, I really don't have any explanation for you, but I know that lots of people love it, so we're going to stick with it for the time being.
I think that's interesting. One of the things you kind of pointed out there is that you find that most people are actually tend to just use a single cloud platform, but having this kind of ability to this agnostic approach, this abstraction above it, I think that's really the root of not just Crossplane, but Kubernetes as a project, right? I mean, this is the reason why folks have been gravitating to Kubernetes. Is it works the same whether you're running on AWS or on premises, as long as you're running on a certified conformant Kubernetes distribution. Of course, EKS being one of those, and Crossplane really giving you the ability to run in that standard environment, giving, I feel like, users the peace of mind that the skills that they're learning and the culture they're building in their company isn't going to be wiped away the next day because it's a general abstraction. And I think that's probably a big reason why people have been gravitating to this project.
Absolutely. And, one of the analogies I like to make, I'm a big fan of hardware. And so I like to look at this kind of as like a Linux level abstraction. And then AWS, GCP, Azure here, right? These are all CPU manufacturers, right? And there are differences, right? You can leverage these in different ways and there are advantages to relying on them. But you do have that standard interface. And, depending on how you leverage the underneath service providers, you're going to get a better or worse experience, perhaps.
Yeah, I think everyone, PC building, everyone loves PCI Express. You can get GPUs from any company, right? And it all works. But the motherboard, you have to decide ahead of time. Are you going with Intel? Are you going with AMD? So yeah, I like that analogy. And maybe I took it a little bit further there. But look, folks, it's 15 minutes on the hour. I think people want to see how this works. Maybe we can jump into a demo here. Manabu, what do you think?
Oh, yeah, sure. Let's jump right into it. Yeah, so just to kind of just show you like what you can do with Crossplane, we are just going to create a bucket, right? Just the S3 bucket. You can see here, we're just creating a kind bucket. So you're essentially just creating a Kubernetes object, and then it's going to translate that into the actual bucket that we can use. So if I were to
And backing up just a little bit, what's required to get to this point of I'm going to create a bucket? Like, how did you get to the point of like, hey, now I can create a bucket? Because I could go do that on a Kubernetes cluster and it's going to say, I don't know what that is. So what got us to this point?
Yeah, so all you really need is a Crossplane. Well, in my case, I'm just using EKS, but you can use any Crossplane. Oh, sorry, any Kubernetes cluster. You can even use like a local cluster, like kind, or you can use GCP. Doesn't really matter. And then once you have that.
Sorry. So we're looking at a EKS cluster here named Crossplane-serverless. So I'm looking in the AWS console here. And it looks like you've got some deployments on here. I'm guessing you've got Crossplane installed on this cluster already?
Yeah. So if you look at the, just looking at the Crossplane system namespace, we can see that we have a Crossplane installation, and then we have a bunch of provider installations, right? So these providers, pretty much like Terraform providers. They provide, functionality to do things, right? In our case, provider AWS is going to help us create whatever resource we want, right? In our case, we will be just using buckets. And you can also have provider GCP, provider Azure, right? Like whatever you want to do. And then you can mix and match to create whatever abstraction you're looking for.
Where does the Crossplane like high level controller fit in versus why wouldn't I just run a provider? If that's providing my interface to the infrastructure, what's the difference there?
Yeah, good question. So these providers, they're responsible for just interfering or interfacing with the these different cloud providers, right? It doesn't have to be cloud providers, but we are just for the sake of simplicity, we're saying that. Now, for this Crossplane, deployment, this is responsible for composing all these resources together. So, like when Dan was saying, right, you could have different cloud providers, have resources, right, and then you can glue them together. So, gluing together and just making sure everything's in sync, all that is controlled by Crossplane. And provider AWS is just responsible for resources within AWS only.
So if we dug into this, we could probably see that the provider is using some secret, maybe some credentials config map with your credentials to your AWS account, right? And obviously we don't want to show that on screen, but that's probably configured, allowing the cluster to be able to communicate with our account.
Yep. So if you look at the this little annotation here, we are saying that to use the IRSA, I'm sure most of you know what that is, but it essentially allows you a pod within the Kubernetes to assume a role based on whatever condition you have. So in my case, I'm just assuming this little role using the pods token.
So it's a more safe approach. Rather than directly having credentials, we're using IAM roles for service accounts, kind of a best practice approach for giving pods or things running in your cluster the ability to access an account. Okay, I think this bit makes sense. So then now what you were showing in the CLI, we would be able to now create things like a bucket or something in the actual cluster, right?
Yeah, exactly. So like we were saying, we are just creating this bucket object within our cluster, and then it should translate into actual S3 bucket creation. So if I were to apply this manifest, should start creating all the objects. So if I were to describe this object, describe should get all the events related to this. So in our case, it's just went straight in. So there's like no actual composition process or anything like that. So we just say, hey, request is actually submitted successfully, and it should be available. And if it's available, it tells you, hey, it's actually available. And if it's not, then it will say it's false, right? And
so
now,
obviously, Manabu, Kubernetes doesn't come with an object type of bucket. So how is this made possible here? How can you tell it to make a bucket? And there's the concept of custom resources here, right? And I know that Crossplane extends that a little bit further.
Yeah. So there is a concept called custom resource definitions in Kubernetes. What just means that they are just pretty much just allowing you to define your own objects. And then these objects are reconciled by whatever controller you have. So in case of Crossplane, we have a CRD is called provider AWS. So that provider AWS is going to create a whole bunch of CRDs that corresponds to different kind of AWS services, right? So if I were to do kubectl get CRD, then just grab for AWS, like so, I should get a lot of those resources, like this. You can see those, right? So you can see here, like I said, there's quite a bit.
So this is pretty cool. You're basically able to see all the different things that you can create within AWS from within Kubernetes, and that's from the generation of these custom resources. Now, one of the things, if I understand correctly, reading through the Crossplane docs, they say, and yeah, I see the bucket, the one that kind of appears there. They say that dev teams really shouldn't be working directly with these types of resources. I think they call them managed resources. Dan, I know you have a really cool graphic on this to kind of show how the different pieces kind of fit together here. Can we take a look at that?
Yeah, absolutely. I'd love to pull the slides back up here. What Manabu was showing there is just the provider install. And we point out, right, that brings along a number of CRDs, and that controller runs as a deployment to reconcile those. And we're seeing that kind of like one-to-one provisioning there. What we eventually want to move to is exposing API types at the namespace scope. So we frequently in the Crossplane community think of the developer view as being in the context of a namespace. Now that may be across multiple different namespaces and can vary a little bit with cluster implementations. But we have this concept of an XRD, which is kind of analogous to a CRD. What an XRD does is it says, hey, I want to create an interface, right? A schema for an API type, much like a CRD. And I may want to offer that at both the cluster scope and the namespace scope. If it's just at the cluster scope, we view that as more kind of like a managed resource or a system level object, something that platform teams might provision singletons of or something like that. If we offer it at the namespace scope, we're saying, hey, this is something that we actually want to offer to some set of developers in a namespace to be able to provision themselves. And so in this case, for instance, you may say, I want to offer a type in the namespace scope for a bucket. And you might have that translate one-to-one to creating a bucket. But a lot of times it takes other resources to actually deliver a full solution, right? There's lots of different resource types on AWS. And so for a developer to actually be able to create a claim of my type in this case, for instance, that's going to translate to eventually matching to a cluster scope type. So this my type claim is going to match to the X my type in the cluster scope. And you have a concept of compositions. Compositions are essentially implementations of infrastructure that satisfy the interface that an XRD offers, right? So let's take a bit of a more abstract approach here. Let's say we want to provision an application. There's lots of different ways you can run an application, a containerized workload on AWS, right? You could run on ECS, you could run on EKS, you might have an EC2 VM that can run containerized workloads as well. Depending on where you actually want that to run, which should be abstracted from the end consumer here, you can give them an interface that says, hey, point me to the container image, give me some resource requests or something like that, and tell me what region you want to run in. Then depending on those, you can match to a composition, which may provision one or many resources on AWS. Maybe it, starts a container on ECS. Maybe it sets up a a VPC and some subnets and firewall rules, spins up an EC2 instance, installs some things on it, right, and runs a container that way. There's lots of different options, but what we're trying to do here is offer an API surface area for developers to interact with, which is higher level or even just your own opinionated view of how to consume services within your organization.
I can't help but think of the exhibit meme here. It's like, yo, dog, I heard you like abstractions. So we put abstractions in your abstractions.
Right.
It really does look like where claims are an abstraction on top of a composition, which in turn is already abstracting the underlying AWS resources. But Dan, why should developers have namespace scoped access only? Why should they be working at this scope rather than the managed resource approach that Manabu showed us?
Yeah. So it's always a spectrum, right? So we don't want to reduce developers to kind of any one sort of role. Speaking as someone who works at a company that's much smaller than AWS, right? Our developers may have very different responsibilities than, a software engineer at AWS. And you may want to expose different APIs to them, or even within an organization, right? You're going to have all different kinds of levels there. So from a very concrete perspective, managed resources exist at the cluster scope, which means that you're missing an isolation boundary of a namespace when you're doing RBAC or creating policies or that sort of thing. So, a namespace is essentially something to attach a policy to. That's one way to view it, right? So you could say, hey, I want to give a developer the ability to do this, and they have this restrictions around provisioning the infrastructure. If you can do that in a namespace, you can attach a policy, say this only applies here, and then group developers in that way. So there's one of the reasons is just that managed resources are cluster scoped. Another one is that you have kind of this full empowerment, I guess, to be able to decide what that API is. So we certainly have folks, and there's actually an open source project in the Crossplane ecosystem today that will translate managed resources one-to-one to an XRD that offers a claim. And that's basically saying, hey, I'm publishing this managed resource to a namespace scope, which means that you can have developers actually create a bucket directly. And maybe it would look a lot like what Manabu showed there. However, what you don't have to do is be held to that single interface or that single implementation of it forever, right? So when a provider installs the bucket CRD, you're constrained from that point forward by how the controller is going to reconcile that. If you offer developers, let's say it's one-to-one representation, so the exact same spec on the claim that you offer for a bucket, you have full power to actually switch out the implementation of that behind the scenes. So if, your organization extends to another cloud provider, extends to another geographic region or something like that, you can then make that change without having to actually break developers in the interface that they interact with.
Got it. It's potentially a way for operations teams to maybe put guardrails around what developers can do. Say, for example, that you can define what region that the bucket gets created in, and the ops team doesn't really want to let the dev team define what region it gets created in. They could restrict them from doing that. That makes sense.
Absolutely.
So,
question just came in about how do you manage the actual access to that for privilege, right? When a developer says, okay, I want to create a bucket, are they creating public buckets? I mean, obviously that's going to be in the interface implementation of what actually gets exposed to them, right? But is that at the RBAC level? Is that at the AWS IAM level? Where does that fall into place here?
Yeah, absolutely. That's a really great question. And unfortunately, the answer is it depends, right? It depends on your model as an organization. So a lot of times we'll point folks to, whatever underlying service provider they're using and best practices there. So we certainly point to AWS best practices and that sort of thing. However, one of the benefits, right, that we keep going back to with the Kubernetes API surface area is that you can define policies across all of these different types of infrastructure, which may have heterogeneous APIs using the same kind of language. So I talked about OPA a little bit earlier. That is a way that we usually recommend for folks to be able to set policy around resources, because it doesn't matter what the underlying implementation is, right? You should use AWS IAM as the baseline for when you're provisioning AWS resources. But if you want to say, we don't let buckets on any cloud provider, at any level of abstraction be provisioned with greater than size X, or we don't let any of them be public or something like that. Using a unified language to be able to do that is really valuable. So it definitely depends. RBAC is a big part of it. One of the things that we kind of say is different about Crossplane in a way is that if you're running an infrastructure as code tool, right, to be able to execute that, you're going to need some credentials to be able to actually do the provisioning, right? At some point, you have to be able to say, hey, I'm someone who's allowed to do this and perform some sort of access handshake with AWS or whatever external service provider. What we like to really emphasize in Crossplane is that you should never, ever be giving developers credentials to be able to create things on AWS. What you're doing is you're saying developers are able to create a bucket, and I, as a platform team, have dictated what that means, right? And I've given the system that I've built the ability to enact on a request that a developer has made for a bucket to exist, but we don't actually want to offer the AWS API directly to developers. And having that abstraction persisted, which is different than actually just rendering down to it's more than just a templating system, right? Both that claim exists and the actual managed resource exists, and they have different levels of permissioning. And so preserving that boundary there is really critical for architecting a system that offers the policies that you need within your organization.
And you brought me back to one of the other comments I saw earlier from Nur, which was probably the understatement of the year, where things don't always go right the first time with infrastructure. I mean, that's just common knowledge if you work with infrastructure. But their actual question was, is there an equivalent of Terraform plan? If I don't have those credentials, how do I know what I'm going to be deploying with this spec?
Yeah, absolutely. That's a great question. There is not a direct equivalent of Terraform plan because the actual Terraform plan functionality wouldn't make sense in the architecture of ongoing reconciliation here. However, one of the things that is a top requested feature of Crossplane and will likely be coming here in the next couple versions is observe-only resources. So when you create a bucket on AWS, you may only specify a few different fields that you want set to your values, and then the rest of them get defaulted. The way that Crossplane providers work is they'll create your bucket and then they'll say, hey, I'm going to get that bucket and see what all the default values were set to. And I'm going to represent that in the spec of the resource now. And then there's obviously some values that are just a result of provisioning that go in the status. We call that process late initialization. So if you have a resource you created that was observe only, essentially what it would do is get that resource and say, hey, this is what it looks like externally, and I'm going to represent that internally, and then you can turn on management of that later. So that's a way to be able to say, hey, maybe you want to create your bucket and then see what it looks like, and then turn on management of it and see how that would react. But in general, right, if you're creating some new infrastructure, deciding how it's going to be configured, Crossplane is going to keep trying to drive it to the specification that you put there. So if you put an invalid specification, right, it's going to fail to do so and let you know. And then you can update it to be able to, switch to whatever implementation you want.
A couple of other questions that popped up related to this track before we jump back to the demo with Manabu. One question about what about the EKS control plane performance with so many CRDs? Is it still working fine? Someone else asked, is it possible to install a subset of CRDs? I'll let either of you take this one because I think people think that CRDs are consuming any kind of running process, and I'm fairly certain it doesn't. Right?
I can start with the EKS side of things, and then I can pass it on to Dan to give some more details on the actual work that has gone into it. But yeah, the number of CRDs was an issue initially, right? The fact that Crossplane in general for every cloud provider tries to provide full coverage basically means that as part of extending the Kubernetes control plane, you now get to install these CRDs that would interface with all the, in case of AWS, 700 different resources that we have, right, for the different services that we offer. So that was a problem to begin with. And then, massive amount of work was put into fixing that problem, coming primarily from Upbound. Dan and Nick Cope from Upbound put in tremendous amount of work into trying to fix some of those issues. I think earlier on, Justin, linked to the blog post where they talk about the solution that they've actually put out that actually helps address some of these questions. The problems were in both sides, both on the Go client for Kubernetes and on the server side. But the fixes are in. The problem is mitigated to a good extent. The newer versions of Kubernetes do not show as much of degradation in performance when it comes to the installation of all these CRDs. I think starting from Kubernetes version 1.24, you won't see a lot of these problems. But the fixes are also backported to the earlier versions of Kubernetes as well. So I think 1.22.11 is the probably oldest version for which you can get some of these fixes and sorted out already. And hopefully that kind of addresses it. Moving forward, the idea of splitting the CRDs to a subset is something that we constantly hear from Crossplane users, from AWS customers using Crossplane. So with that, I just want to pass it to Dan to provide some insight into that as well.
Yeah, absolutely. So that definitely has been a long-running request. One of the things I want to point out about the architecture, right, is providers are totally modular. So you could implement your own with less CRDs or something like that, or you could use the full approach like we use with most of the providers we contribute to as Upbound. One of the reasons for not restricting the number of CRDs that are installed is the developer experience. So anytime you're kind of building a tool that folks are going to interact with to be able to perform operations, it's really important to make it easy to have a good time, you might say. And so a big reason for making sure all the CRDs are present is that if you say you have provider AWS installed on your cluster and I have it installed on mine, that we can verify that we have the same content actually present. There are a few different mechanisms that have been proposed for limiting the number of CRDs that are installed or allow listing or deny listing, right? A set of CRDs. All of those mostly revolve around how provider installation works. So putting kind of a list of what would be allowed or not, say, maybe I just want all of the ones that are in the s3.aws group, right? Or something like that. Like I said, that's not something that we've wanted to support right now as a group of Crossplane maintainers, but it is something if ultimately you had to, providers are totally open source and there's frameworks to be able to do that.
Well, today I learned that when you have that many CRDs, you could potentially get degradation of the service and the API server. That's very interesting. Folks, I do want to jump back to the demo here. I know Manabu's got a few more things that he wants to show us here.
So let's see here. I just wanted to go to this repo. This is the Crossplane on EKS repo that we maintain. It has a bunch of compositions that you can use. And kind of want to just highlight what Dan was saying. So if we were to go into this, this repository and then look at, say, like S3 composition, and then look at the general purpose YAML file here, we can see that we are defining a object called X object storage. And then this has just one resource. In this case, we're just saying that it's an S3 bucket. And then you can see that in here, we are just enforcing certain requirements that you have, right? So in our case, we are saying that, hey, any public access, they're all disabled. And ACL is set to private, and then you have to use the AES 256, right, for SSE. So whenever someone uses this composition to create an S3 bucket, all these is baked in. And not only that, it's actually continuously reconciled. That means every 60 minutes or so by default, it's going to enforce this rule, right? If someone changes like encryption configuration or whatever, we just get right back into what it's supposed to be.
So that's fitting one of the core kind of tenets of these DevOps tools, continuously reconciled. Obviously, also one of the core tenets of GitOps as well.
Exactly. So I have a example object storage file that I can use. So here I'm just saying that, hey, I want the object storage, and just giving some information like, hey, I want it in the US West 2 region, and then I want to use this kind of provider, and then that's it. You're not exposing any information about the bucket itself, right? I'm not telling you what kind of encryption I want to use, what kind of ACL I want to use, any of that. None of that is available here. And these object storage, these CRDs are defined by you, right? When you write an XRD or composite resource definitions, these XRDs translate into the actual custom resource definitions that you can use. So if I were to apply this manifest, I should get the bucket that I want to use, but without specifying any of the actual details that I have to worry about. And the search. So, if I can actually spell. All right, then you can see that this is a claim, like Dan was saying. So claims are namespace. So in our case, this is, I believe, in the default namespace here, you can see. And this is just pointing to the actual cluster resource. In this case, it's this X object storage. So if I were to describe this object, I should get the actual object that's being ready. So it says, it's available. And if I would go to the console, I should see the bucket that I just created. So if I see.
Yeah,
the claims work a lot like persistent volumes, right? In Kubernetes, we have this default of like, hey, I have storage that I need, and someone needs to create the thing, and someone needs to claim the thing, and that's how it basically gets bound to my application. So this already exists in Kubernetes as a thing that's already there for lower level resources, and we're just extending that into what if that storage was an S3 bucket? And you could do that with storage. Like I have a provider that provisions S3, but we want to do it for generically anything, right? So that's how claims and these XRDs work inside of Kubernetes.
Yeah, that's a great call out. And actually the initial inspiration for some of the systems that predated composition in Crossplane were modeled after persistent volumes and persistent volume claims. One of the things that Manabu showed there that I think is really a powerful feature of this is that use of the composition selector. So in this case, it looked like you had a few different labels there that you were using to say, hey, these are kind of the attributes of the composition that I want to match to. You can think of it like this is the attributes of the implementation for the interface I'm requesting here. In this case, right, we're saying provider, environment, configuration, etc. Within your own organization, though, you can kind of define your own schema for how you'd like for folks to be able to schedule to environments. And you can also use policy on that, right? You can say, hey, in this namespace, you're able to provision to the dev environment. That can be enforced via policy, or you can do things like mutating webhooks, right, that set that automatically for you. So there's a lot of flexibility in how you want to actually say, hey, when a developer requests this abstraction of infrastructure, what actually happens behind the scenes and what factors does that depend on?
Oh, that's really interesting. So when you make a claim, you can not only map to a composition, but if there's multiple compositions that could respond to that claim, defining the match labels here in the composition selector. And I see you've got one for environment dev. So for example, maybe there's another composition for environment prod, which uses a different encryption scheme, or some of the other pre-baked variables that you had showed us in the composition earlier. That's pretty cool.
Yeah. And you can actually, since we are just saying that it's an object storage, this provider doesn't have to be AWS, right? You can actually have your own data center and that provides this kind of functionality as well. Or if you're going to Azure or whatever, right? So it's a quite powerful abstraction you can have on top of these different cloud providers.
Okay. So Manabu, I think a lot of what we saw today, we kind of assumed that you are the operations team and the developer. You're playing both roles here. You're setting up Crossplane, the credentials, the provider, and you're creating the buckets. But in reality, you're probably going to have two separate roles that do this, right? One team that sets up the Crossplane, the credentials, the CRDs, the compositions themselves, and then another team that creates claims to apply them. And we know Crossplane really goes hand in hand with GitOps as well, as it's a continuously reconciled tool, of course, running Kubernetes, and can work really well with GitOps type approaches where you have all of the configuration in kind of a configuration repo. And of course, Kubernetes YAML being declarative. It really fits the bill very well there. And I see already you're showing Argo CD here. So let's kind of see that perspective of what would a dev experience be like with a cluster like this?
Yeah, sure. Before we get into the dev stuff, I think I want to just show you what the experience looks like from a platform, team's perspective, right? So I have a application, let's just say compositions. This is responsible for applying any compositions based on certain repository. So I actually have a pull request already ready to use. So in this case, I'm just syncing from this particular repository into the Argo CD. And here I am defining just one composition. This composition is this Lambda function. So what this does is just going to create Lambda function, right? But when you are creating Lambda function, there are two things you need, right? But minimum, you need an IAM role that you can attach to the function, and the function, binaries, pretty much. So all that is encapsulated within this definitions, and I am about to just merge this. So imagine if you are a platform team, and then someone from your team creates this composition, right? And then create a PR, and then review these changes. Then okay, everything looks good. Then say let's just merge this, and let's see what happens when you merge this particular commit. And if we are able to go back to the Argo CD and then refresh this, it should start pulling.
So what we saw there is it's your config repo, which is a common paradigm when doing kind of GitOps type approaches. And so you've got that config repo, you're deploying a set of compositions to it, and so feasibly Argo CD should pick it up.
It should, yes. Hopefully it does.
When it does.
Yeah.
I think while Manabu is waiting for this to be pulled in, I want to go back to one of the things that Dan mentioned earlier, and we've been looking at it. You see that we deploy an S3 bucket, but then we call it describe, a kubectl describe on that S3 bucket to check the status of the bucket, as part of the resource definition that Kubernetes returns. That particular experience is the part of appeal when it comes to Crossplane, that you can actually put that umbrella around interacting with resources that are completely external to your Kubernetes cluster from within Kubernetes. Now hook up your observability tools to it, hook up like the other pieces and instances that you have to it, right? And all of a sudden, everything that you are bringing into your Kubernetes cluster for you to manage your applications can extend to manage your infrastructure as well, which is like super awesome when it comes to identifying and understanding and unifying that experience. Going back to the very early thing that I said, right, that it's about standardizing and unifying approaches. So,
absolutely. Another thing that I think is a good thing to point out here, especially in the context of these AWS blueprints. I just dropped a link in the chat here to an example of a configuration package. We've talked a lot about provider packages, and what Manabu is doing now here is, adding some configurations and or some compositions and XRDs right to the cluster. Another thing you can do once you've kind of got your API and implementations where you want them is build them into a package called a configuration package as well. And that means that anyone in their kind of platform cluster, right, their Kubernetes cluster with Crossplane installed, can then take that and install it and get all of those API abstractions and actually form dependencies on top of them as well, which is a really cool experience. For instance, right, we have folks that are always building on top of AWS and wanting to expose maybe some best practices. So all they need to do is install that AWS Blueprints package, and they suddenly have a set of APIs that they can offer to developers that are, following architecture best practices from AWS. Which is a really nice benefit of the package dependency resolution in Crossplane.
Right, and I think we're seeing that right now from Manabu's demo, and it pulled the compositions. And I just want to touch on that, Dan, about how the blueprints that we have here in that repo, they're really a best practices approach. So for example, out of the box, the AWS provider is going to have a resource for, let's say, an Amazon EKS cluster. Let's say you want to make more clusters from this Crossplane EKS cluster. But that's just the start of it. Not only do you need the EKS cluster, but you might need some VPCs, some subnets. You might want to install some additional add-ons. Maybe you want Carpenter for auto scaling. Well, with that repo that we've linked, the Crossplane on EKS, we actually have best practices compositions that use managed resources under the covers and let you do namespace scoped creations of things like claims to run against those compositions. So we mentioned already, managed resources out of the box. You probably don't want your devs to be using those. You want them to be working with compositions and claims. And I think that's what you're showing here, right? Right, Manabu?
So this is showing a compositions that's propagating into different resources that's managed by the Crossplane pods. So right here, we have a composition resource definition. This object is responsible for managing all these resources. But most of these, you don't really have to worry about. So now, I'm say like, I'm a developer, and I want to take advantage of this Lambda function that was just defined. Then all you do is you go to your repository, right? I have this just CFC demo, just has a definition for Lambda function. So here I'm just putting certain information about this Lambda function that I need, and then if I were to merge this PR, it should start creating the Lambda functions that we just defined. So if I were to merge this and then go back to the Argo CD and then look at this guy. So this application is syncing to that repository that we just merged the PR into. So if I were to refresh this, it should start creating all these functions and all the resources that's necessary by this function to function, right? So here we see that it created a Lambda function. This is the claim here. And then this is the actual resource that's responsible for managing all the other resources. So here we just created a IAM role here. And then once this IAM role is created, it's going to create the Lambda function as a result. Just waiting for that to happen here. You can see that it created a role, and then finally you create a function. And also there's a role policy attachment. This is available responsible for attaching whatever policy you defined to this role.
So Manabu, earlier we saw, I think Dan was showing a graphic of XRDs, the compositions, the managed resources, and then on the bottom half there was a claim. So can we see each of those resources on this chart right here? Can you kind of walk through it from that context?
Yeah. So these role policy attachments, role, and function, these are the managed resources. Like Dan talked about earlier, these resources shouldn't really be exposed to your developers, right? So that's why these are child resource of this Lambda function or X Lambda function.
Okay,
Now,
so just very quickly, we did get a question related to this, so I want to kind of tie it into that question. David, new to Crossplane, he says the resources aren't namespaced. And so if he wanted to create 10 EKS clusters, he'd want to be able to organize the resources by namespace. But that's what we're seeing there. The managed resources, those three that you showed, those aren't scoped to a namespace, right?
Right.
That's exactly right. And one of the things that's nice here, though, is we're able to actually see where those managed resources came from, right? So they weren't just rendered out and applied. We're actually able to see, hey, those are linked to a namespace. So while the actual resources themselves exist at the cluster scope, we can see the claim that has claimed them, right? That they're linked to. One of the actually interesting things you can do is you can actually kind of like pre-warm resources if you want to. So you could provision resources at the cluster scope and then have them ready to go when someone wants to create a claim. You just match to them already provisioned, right? So in that case, if you wanted 10 EKS clusters and you wanted all of the, actually really love this question, you wanted to organize all of the cluster's resources by namespace, what I would say is that you should have a cluster claim type, right, that has all of those resources. It composes all of those resources. Create one instance of that cluster type in your namespace, and that would render out all the resources you wanted. And you'd have that concept of a cluster, right, your EKS plus all the other bits. And that would be represented in a namespace scope for which all of the managed resources would be linked to.
Right. So I think it's tempting for someone who's new to Crossplane to work directly with the provider and directly create managed resources, but you'll find that that's sometimes limiting because you want to put guardrails around it, and that seems exactly the perfect job for claims driven by compositions.
And you can nest the compositions too. That's another thing that is super interesting. Like you can actually put wrappers around wrappers, and then it expands to this massive thing that has multiple layers to it, which could be super awesome if you want to hide all of that complexity from the users.
we have to wrap up. And I know there's still comments and there's still demo. And so, but we have to cut short because there's another show after us. So where should people ask more questions and get started to get involved?
Yeah, that's a good question, Justin. And I want to wrap this up by basically mentioning to people the set of things that we do. First of all, throughout this demo, you saw a lot of references to this AWS Labs Crossplane and EKS blueprints that we've put out. This is a repository that we maintain and put best practices on how to run Crossplane resources on top of AWS for AWS users, right? And you can certainly go there, engage with the maintainers, and provide us feedback, and we can help you out through the process of getting up to speed with running Crossplane on top of your EKS cluster. But another thing that we do is that we have this 8-week program that we can actually collaborate with you on building some of this stuff into your own AWS accounts and your EKS clusters. If you're an AWS customer, this is something that you can get absolutely for free, and you get time with the AWS experts and Crossplane experts. We work very closely with Upbound and Dan and colleagues in order to enable AWS customers to be able to actually get up to speed with Crossplane and EKS. So you can certainly reach out to us if you want to be part of the program. Obviously, there is a lot of people who want to actually go through this program, so we have to prioritize and we have to line you up and put you in the queue. But we're more than happy to provide this service to you and help you out. And as I said, it's absolutely free if you're an AWS customer. Last thing, in order for you to be part of this, this is some of the contact info that I've put out for myself, for Dan, and for Manabu. Reach out to us on LinkedIn or on Twitter, and let's have a chat. If you want to know more, if you want to get involved, if you want to participate in the open source community, if you want to build with the Crossplane community, it's all options that are on the table, and we're happy to help you out and get you to the next level in this journey for sure.
Awesome. Any final words you want to leave our folks with here, Dan? Anything you're looking forward to? Anything you're excited about with the Crossplane project?
Yeah, there's a lot of upcoming features in Crossplane that I'm excited about, but what I'd really like to say to finish this off is everyone is welcome in the Crossplane community. So if you're interested in contributing, learning more, getting involved with this program that Nima was just laying out there, please do show up in Slack, ping us. We're more than happy to help you get started in whatever capacity you're interested in.
Awesome. Thanks, Dan. And thank you, Manabu, for the awesome demo. Thank you, Nima, for joining us. And of course, to my co-host, Justin, today. Thanks to all our viewers out there that are watching. Be sure to subscribe and stay tuned for more episodes like this in the future. Thanks again for watching, and we'll catch you next time.
Thank you.